Okay, I wanted to go through a number of factoring questions. A number of students have had questions on this, and maybe looking at it from a perspective of where do you get the numbers from to factor something like these. Okay, so this first question asks you to factor, check by multiplying. And so I look at it and there's only two terms. Let me use a different color. There's only two terms there. And I guess irregardless of whether there's two terms or not, the first thing I do every time they use the word factor is I look to see if there's something that's common to each one of those terms. And what I mean by common is there something I can divide each of those things by? So let me rewrite it. So 2x to the 9th minus 10x to the 7th. Let's look at numbers first. So is there a number that will divide evenly into both 2 and 10? 2. And I guess you can do that by looking at they're both even numbers. Also 10 is 5 times 2, so there's a common factor of 2 in there. So what I can do then is I can divide both of those terms. Let me write it out like this. 2x to the 9th minus 10x to the 7th. I'm going to divide both of them by 2. So I'm factoring a 2 out. And when I divide them both by a 2, what I need to also do is put a 2 out front here, because that's what I'm factoring out. Okay, also now I can look at the letters, and I want to look at how many letters are common to each one of them. So I have x to the 9th here and x to the 7th. In this case here, I'm not looking at the 9 and 7 as to see what number each will divide by. Since they're exponents, if I'm dividing or multiplying bases with exponents, I either add or subtract. So I'm not looking at dividing them, I'm just looking to see how many x's I could take out. Well, this first one has 9 x's and this one's got 7, so at most I can take 7 out of each. So I'm going to divide each of them by x to the 7th. And again, that is a number, since I'm taking that out of each of them, I need to put that as a common factor out front. So I have 2x to the 7th. And then inside here, the 2's cancel, so I'll just have a 1 there. Usually I don't write that. But then if I'm dividing common bases, I subtract their exponents. So 9 take away 7 is 2. So I'll be left with x squared on that one. Okay, minus 10 divided by 2 is 5. And then 7 divide, or x to the 7th divide x to the 7th. Subtract exponents, I get x to the 0. And anything to the 0 power is 1. Or if you want to think about it as this is the same as this, so it cancels, so there's no x's there at all. So this would be the answer to that question, where I've done a common factor. Let's try this next one. Different type of factoring. First, though, always look to see if there's something common. Here I've got an A, an A, an A, no A's. So I can't factor an A out. That's out. So there's no common factor, but they say factor by grouping. So to factor by grouping, I'm going to take those two terms and just look at them, and then take these two terms and look at them, take out a common factor from each one, and then see what's left over. Okay, so I'm just going to ignore this for a second. So I'm looking at this first one to see if there's a common factor. There's not a number that's common, but there are some a's that are common. So there's an a squared that's common. If I take that out of a cubed, it'll be just an a, minus 3, an a squared out of a squared, I won't be left with any a's there. Again, if you need to write over here that you're dividing each of those by a squared, if that sort of helps you figure things out, like 3 take away 2 here, that's where I get the a to the first there, and the a squareds cancel, that's why I just have a 3 in this spot. Okay, so that's the first one. Now let's bring this back and do the same thing with that. So out of these, what's common? Looks like a 5. A 5 will divide in each of those. So I'm going to put a plus 5 out here. And then I'll take the 5a minus 15 and divide them both by 5. Here the 5's will cancel, leaving me with just an a. 15 divided 3 is 5, so it'll be a minus 3. Now when you're group factoring, at this stage here, what you're looking for is, you're looking at this term and this term, and you're looking for a common factor. And in this case here, I've got a common factor of a minus 3. Just this piece right there is common to both of those. So I can pull an a minus 3 out front, okay, and if I divide this term and this term by a minus 3, I'm going to be left with a squared plus 5. Again, if you wanted to over here, you could go, this is my first term, and here's my second term, and I'm dividing them both by a minus 3, because that's what I took out, a minus 3. So this one cancels, left with a squared right there. These cancel, left with a 5, that's that right there. And that's the end. So that would be a factored form of that. If you wanted to, you could check it. And you could take and go a times a will give you a cubed. And then a times 5 is be a plus 5a. Minus 3 times a squared is minus 3a squared. Minus 3 times 5 is a minus 15. And then compare this, collecting like terms if you had to, with the original question. And sure enough, other than this order, they're exactly the same. Okay, let's try a couple more. So here they say factor the trinomial. So if I have 3 terms like this, typically I can, and I can take a shot at it, break that into 2 brackets. Not really break, I should use the term factor. So I can factor that into 2 brackets. So what I'm looking for is I want to find 2 numbers that multiply to this last number, 20. So what multiplies, maybe I won't put a 2 there. So I want to get 2 numbers that multiply to 20, but those same 2 numbers have to add to 9. Okay, well, to multiply to 20, there's a ton of numbers that will do that. 20 times 1, 10 times 2, 4 times 5. Also, if you count the negatives, you could go negative 20 times a negative 1, negative 10 times a negative 2, negative 4 times a negative 5. Now, you have to pick which of those actually adds to a positive 9. This one adds to 21, that's out. 12, out. 9, that's my numbers right there. So I can take those numbers and then I'm going to put them in my factors. So this a squared splits up into an a in this bracket and a in that bracket, and then I just take those 2 numbers and put them in the other spots. So I'd have a plus 4 and a plus 5. Now, according to the commutative law, that it doesn't matter what order things go in, I could also write it as a plus 5 times a plus 4. Both of those are identical. All right, let's try this next question. It says factor the trinomial. Okay, always look for a common factor. I forgot to do that up here, but there wasn't one. But look to see if there's something that's common to any one of those 3 terms. It has to be all 3. Looks like there's a y squared for all terms. So I'm going to take a y squared out. That'll leave me with y squared plus 12y plus 27. Again, if you needed to, over on the side here, go y to the 4th plus 12y cubed plus 27y squared, and divide each term by y squared. That's what we're doing when we're taking out a common factor. Here, 4 take away 2 gives me the squared. 3 take away 2 gives me just that plain y. And then here, the y squareds cancel, leaving me with just that 27. Okay, so I factored out a common factor, but typically I want it factored completely. So now I have to do the same thing as I did up in this question. So this is a trinomial, and it's of that form ax squared plus bx plus c. It's a form you might have seen before, but it's that something squared plus just a something plus a number. So if it's of that form, then it's possible that I can break that down into 2 smaller factors, or linear factors we would call them. Okay, so now I want to key on that 27. So I want to find two numbers. They have to multiply to a 27, and they have to add to a 12. Okay, well, 27 times 1, 9 times 3, well, there it is right there. And 9 times 3 adds to a 12, so those are my numbers there. So I'll split this y squared up into a y, and then I'll put a plus 9 here and a plus 3 there. Done. So that would be my fully factored form. Let's try factor this one. Ooh, big numbers. Fun. Oh, common. Let's see if there's something common to all of these things. So is there 2 is common. Can I go more? Maybe 4. Let's try it 4. So I'll take 48w squared plus 52w minus 140. Let's see if all of those can be divided by 4. The first one I think gives me 16w squared plus 4 into 52 I think is 13 minus 4 into that 35. I think that's right. Okay, perfect. So I've taken out a common 4. I always want to completely factor. And I notice that this is that same thing. Something squared plus just a w minus or plus a number. So if it's like that, then it could be written like that. Now, this is where in the past, hopefully you've done some factoring, where they look at something called an AC method, or they look at a guess and check method. I'm sort of the guess and check kind of method, especially if I've got big numbers here and here. And so what I do is I just take and I break them down, just like I did on that last one, where I had an a squared plus some stuff. I just split that a squared into an a and an a. I'm going to do the same thing here. And there's different options, but I'm just going to guess and check. 16 is 4 times 4. So I'm going to think that maybe that's a 4w there, and that's a 4w there. But what I'm doing is just guess and check. I'm just taking a shot at it and see if it works. Now 35 is 7 times 5, or 35 times 1, but I'm thinking a 7 and a 5. So since 4 and 4 are the same numbers, it doesn't matter where I put the 7 and the 5. So put a 7 there and a 5 there. Now I've got to figure out minus and pluses. Since this is minus, that one has to be a minus and one has to be a plus. Let's just guess. Let's put a minus here and a plus there. Now I've done all my guessing. Now I need to do the checking. So let's check. 4 times 4, 16w squared. Yeah, I knew that. 4 times 5 would be a plus 20w. Minus 7 times 4 is a minus 28w. And minus 7 times 5 is minus 35. Notice I always guess the first and the last term correctly. But now when I subtract these, I get a minus 8w. But I'm supposed to get a 13w. So something must be wrong. So let's try again. So this is guess number 1. And that gets a big bzzzt. So let's try another one. Let's try, I'll put a 4 here. Maybe instead of a 4w and a 4w, maybe it's an 8w and a 2w. Because 8 times 2, that'll give me my 16. So now I'll probably go 3 and 5 again. Let's try, say a 3 here and a 5 there. Okay, and let's do 1 minus and 1 plus. So, 8w times 2w is 16w squared. Yeah. 8 times negative 3 would be a negative 24w. 5 times 2 would be a 10w. 5 times a minus 3 is a minus 15. So if first and last are correct, this gives me a minus 14w. I'm supposed to get a 13w. Bzzzt. So, guess number 2, wrong. Now, just looking at the numbers, I guess another option I could do is I could do a 4, 8w minus 3 and a 2w plus 5, 16w squared plus 40w minus 6w minus 15. That doesn't give me 13. I don't know. Maybe let me try one more. Oh, I'll just go down, sorry. Let me go down. Okay, let me try another one. So I have the 4 out front. And then instead of a 4 and a 4 or an 8 and a 2, let's try a 16 and a 1w. And then I have, oh, I did something wrong on that last one. And this often happens, maybe you noticed that already, but this often happens when you're doing guessing, is that you're dealing with lots of numbers and they might get fuddled up, just like happened to me here. So right here, I should have used a 5 and a 7, but for some reason I put a 3 in there. Let's try a 7. So that'd be 56. And 10, oh, that wouldn't work either. And if I put, that'd be 40, 14, that wouldn't work either. Yeah, I guess even putting the 5 in there wasn't gonna work either. That guess didn't work. Okay, let's try the 16 one. Just one last shot. And I'm using a plus 5, and a minus 7. So I get, that's not going to work either, because this times this is going to be, what, 102? And 5 times 1 is 5. Even if I put the 7 there and the 5 there, it won't work. So if I've done all of that work, if I've done all that trying to guess and check and figure out two factors that'll work, I probably at this point would say I can't factor it anymore, so I leave my answer right there. Okay, so there's some guessing and checking. Let's try another question. This one says factor completely. Looking for a common factor. I don't see a common factor, but I do notice that it's two terms right there, and there's a minus in the middle. So I think that this might be a difference of squares question. And to know that it is, I look at each term and see if I can take the square root of each one of them. Or is there the same number multiplied together that'll give me that thing? And sure enough, there is. So if I have 4c squared minus 121, I can break it up into the two brackets. I split this one into 2c and 2c, and I split this up into 11 times 11, because that gives me 121. Then one of these is plus, one of these is minus, done. Okay, here's another one. It's a trinomial, and I can do it the same as I've done the others. S squared plus 12s plus 36. So I'm looking for two numbers that multiply to 36, and the same numbers have to add to 12. So they multiply to this, add to that. So 66, or 36. 36 times 1, 12 times 3, 9 times 4, 6 times 6. Oh, they have to add to 12. There's my numbers right there. Factor, split this up into S and an S, and then I have a plus 6 and another plus 6. This would be called a perfect square. Since both of those factors are the same, you can rewrite it as S plus 6 squared. So this and this are the same. Just a couple more questions. This one, factor completely. Okay, common factor. It looks like there's a common b. So I can take a b out, left with b squared plus 10b plus 25. This is that quadratic, and so I look for two numbers that multiply to 25 and add to 10. 25 and 1, 5 times 5, there it is right there. So I can rewrite that as 2 brackets, split the b squared up, split the 25 up. Again, since both of these are the same, might as well rewrite it like that. Okay. It's interesting how some are real easy like that, and some like that one, I kept going on for 10 minutes and didn't have the right answer. Okay, last questions. These ones are similar to the ones I did on a slide or two before, where there's 2 terms and there's a minus, but here there's 2 terms and a plus. But these are known as a difference of cubes, this one, or a sum of cubes, this one. And so what I do is I take and I say, well, if it's a difference of cubes, let's find what each of the cubes are. So I have a b that's cubed, and then 27 is 3 cubed. Once I know what those are, then I can use a formula. And the formula you'll be given on a test is this: a cubed minus b cubed. If you factor that, you get a minus b, and then a squared plus ab plus b squared. So now I just have to follow this pattern, but with these things here. So my a is going to be that b, and the b is going to be 3. So I just plug those in. So over here it'll be b take away 3, and then b squared plus b times 3, which would just be 3b, plus 3 squared would be 9. I could write 3 squared here, I'll just write 9. So that would be the factored form of that. The next question, same thing. There will be a different formula for it. It looks like this: a cubed plus b cubed is a plus b, and then a squared minus ab plus b squared. But I need to know what these 2 things are. So let me look at the c. I have to get c something cubed. So there has to be a number in here. And this is a power of a power, so you multiply. So I need to come up with 6, so this has to be a 2. So that's c squared plus, they gave me 27 again, that was kind of them, same number. So whatever this is goes where the a goes, and this thing goes where the b goes. So let's do that. So a is c squared, so I'll put a c squared there, plus b is a 3, and then this will be c squared squared. So that would be c to the 4th, minus c squared times 3 would just be 3c squared, plus b squared. b is a 3, 3 squared would be 9. Okay, I hope that gives you a little bit better understanding of how to go about factoring some of these questions. Try some on your own. If you have more questions, give me a call.